Okay, we're live. LeetCode Daily. What is that? All right. Minimum time visiting all points. On a 2D plane, there are n points with integer coordinates x, y. Return the minimum time in seconds to visit all the points in the order given by points. Okay, so we have this list of points and the xy coordinates. You can move according to these rules. In 1 second, you can either move vertically by 1 unit, move horizontally by 1 unit, move vertically square root 2 units. In other words, move 1 unit vertically and then 1 unit horizontally in 1 second. Kind of a confusing way to say that. Just feels like you could just say move diagonally. You have to visit the points in the same order as they appear in the array. You are allowed to pass through points that appear later in the order, but these do not count as visits. Okay. Step 1. Understand the problem. All right, so let's just, I think I get it from this description, but I just want to check this out. So here we're given 1, 1, 3, 4, and negative 1, 0. So from 1, 1 here, we can go diagonally up 2, then, so that's 2 seconds, and up 1, so that's 3 seconds. And then negative 1, 0, you can go diagonally down 1, 2, 3, 4. So 3 seconds plus 4 seconds equals 7 seconds. So I think I get the problem, despite that confusing diagonal. So get 2, brainstorm solutions. Okay, so my first instinct is to like simulate this, but I think that's a bad idea because simulating it is going to take more time than just doing math, because I think you can math this out. So by that, what I mean, math it out will be quicker. Like if you had a loop that was like, I need to move from 1, 1 to 3, 4, and you were like, okay, well, let me take one step and then recalculate what to do, and take another step and calculate what to do. You don't actually need to like simulate the state of the world where you're in between these points. You just need to say, don't need to simulate world between points. Just need to say how long it would take. So I think the key here is going to be, you know, obviously, the diagonal is pretty big. I think the diagonal is like why this problem is at all challenging. Because ideally you would move diagonal as much as you can, like, because it's like the same amount of time to move as like it's a shortcut. So maximize diagonals. And what that's leading me to believe is like, is the delta between x1 and between like my x and next x greater than or equal to delta between my y and next y. And when I say delta, like this is in magnitude, not what is the opposite of absolute? Like not magnitude, absolute values. I guess like relative values. So 1, 1, 3, 4. The delta between my x here and their x is 2. And delta between my y and their y is 3. I guess the only thing is that you have to make sure it's in the same direction. I forget the mathematical term for that, but because you wouldn't want to do, if you had 1, 1 and negative 3, 4, the delta between my x and their x is 4, and the delta between my y and their y is still 3. But you can't move diagonal 3 because, well, let's see. Let me just gonna open up Scaladraw from yesterday's or something like that. One, two, three, four. 1, 2, 3, 4. 2, 3, 4. Okay, so we're here at 1, 1, and the two possibilities that are interesting are 3, 4. So 3, 2, 4 here, and -1, 2, 3, 2. Oh, I guess you can't. I think that this is actually because here it's just like it's just the differences in what direction, but it's still like the distance is still the same. So maybe it actually doesn't matter that they're in quote unquote the same direction. Is there one that if it was -3, -4, yeah, it's still, 1, 2, 3. Oh wait. Sorry, this is my drawing here is not helping me. 1, 2, 3. This is 2, 1, 2. Here. And then 3. Is that right? Interesting. Wait. So I've confused myself with my bad diagram. So you can get to, we know this first case, but let's focus on the blue case. You can get to 0, 2 in 1. You can get to 2, 1, 2, -1, 2 in 2. You can get to, yes, okay, it's just that the distance here is not good. You can get to -2, 4 in 3, and then you have to spend your last one here, 4. So it's not the same. Because this is just over here, red. This is 2, 3. 1, 2, 3. Okay, so it doesn't matter. So how do I account for that? How do I account for the fact that this matters? What else besides magnitude? Yeah, I mean, simulating it would be easier. It's like, what direction to go, or you would be like, which direction gets me closest. And just missing something easy. So, I want to look at so we have 2 examples here, one of which is from the LeetCode example. Let's look at this second LeetCode example. 3, 4, middle 1, 0. I guess like if you include the direction, it's like this direction is -4 and this direction is also -4. So maybe that's something, maybe actually just saying it's the magnitude is wrong. Maybe the magnitude was a red herring for me this entire time. This is x delta, y delta. This is 2x delta. 2y delta. Okay, I think I just got too complicated. I think solution is like calculate distance between x and y, me and next. Minimum is number of diagonals you can use. Maximum, which is the other number since there's only 2, is the remaining horizontal or vertical steps you must take. And then, okay, yeah, I think I've described it enough. I'm going to do step 3, move step 3. Yeah, I don't know. Pseudocode. So, okay. So for each pair of points, me and next, delta x equals me dot x minus next dot x, something like that, and then delta y equals, I don't know if this is pseudocoding enough, and the number of diagonals equals the minimum between these two. Number of horizontal slash vertical equals, you have to take the maximum between the two deltas and subtract the distance you already got. Minus number of diagonals. Add both of these to running sum, and then the return running sum. Something like that. Okay, so let's walk through this. So the first pair of points would be 1, 1, and 3, 4. So 1, 1, and 3, 4. So your delta x would be 1 minus... Oh, I have to be careful about minimum and maximum here, I think. Well, let's see. So here would be -2, and yeah, I do have to be careful about this. And and 3. Sorry, I'm thinking about ahead. And -3, right? Number of diagonals. So this would be, is the minimum between, is it the absolute value of this? Let's see. Because I know that works for this case, but what about this case? -3, -4. So the deltas here is -4, -5. Okay, because it's the difference. I think this is working. Okay. And then that would be 4 and wait, can I do it in 4? What am I missing here? All right, I'm only 10 minutes in, so I can take some time to think about this. Is there something about I have to be sign aware? Correction. Oh, I'm a fucking idiot. It's not down here. Oh, this is not -4. This is 4. So this would be 4 and 3. Yes. Okay. So the minimum between these two is number of diagonals equals 3, and number of horizontals equals 4 minus 3 equals 1. So that would be 4. Okay. I don't know what happened there. I tricked myself up. So number of diagonals equals min of abs of -2 and negative abs of -3. So the number of diagonals equals 2. Number of, or is it vert equals 3 minus 2. And this is again man, I've gone full circle. This has been a little bit of a mess. Yeah. Let me just do one more edge case, which is there's no diagonals. So like 1, 0, and 1, 10. You're just going up 10. Number dx, like delta x equals 0, dy equals -10. So number of diagonals equals the minimum of the absolute values of those two. So it's min 0 and 10 equals 0. Number of horizontal / vertical equals 10 minus 0. Okay. Man, I've come full circle. It is just the magnitude. The magnitude is important. I think that I accidentally, in one of my examples, I don't know, I messed myself up. But, okay, so I have my pseudocode. Alright, I'm 15 minutes in, coding's not too bad. So, think I need a... Let me just check it quickly. Oh, it's already imported. You don't need to import it from 0. Fuck, I forgot. What is the runtime before I got to coding? Runtime complexity. So for each pair, you're just doing a little bit of math and then storing integers. So that means that it's runtime complexity, where n is number of points. Time complexity is constant because all we have is, just a few variables for storing the results, and and you have 2 points, you could have 1,000 points, it wouldn't change. So my bad for not talking about that. Okay, let's try this out. Cool. Nice. Do I get my little... Oh, is there a new daily? Did it just come out? All right, I'm not going to look at that right now because I don't have time.